from the beginning. There was much laboratory research and biology and bioinformation given today. Mine presentation is absolutely opposite and completely different. This is information and it's not advancing. Do you see a black screen that says
presentation outline?
Yes, but I'm trying to exit because it's not responding to me exiting out of this screen. What? It worked perfectly on Zoom last night. I had a overseas presentation last night. I'm going to stop sharing. I'm trying to see gas facilities that create energy for us and fuel our world. So we can turn on lights, so we can travel in vehicles and airplanes, so we can have power stations and ships and everything that are fueled by everything fossil or solar, thermal insulation, or even by batteries. Thermal insulation is required. One of the mechanisms that degrades heavy industry equipment is the water internally getting into an insulation system if that insulation system is water absorbent. Throughout the last couple, 4 decades, our industry has progressed. See, it stopped advancing again. I'm going to have to do this from I'm going to have to do this from this mode and share this way, I think. This is very strange. The internet has been causing much problems. So this is going to be very boring for most of you that work in laboratories, but we have extremely large energy facilities, refineries, and petrochemical plants that rely on heat energy to be able to fuel the reactions and vaporizations and processing of crude into all of the raw materials that we use to provide energy to our world. And that requires a lot of heat energy, to millions and millions of BTUs per hour, even in one single facility. And there are hundreds of refineries around the world that are necessary in order to fuel what we do on a daily basis. But whenever we introduce mechanisms that equipment and its insulation system allowing water to get in, that long-term wetness has some very, very important adverse impacts on the ability for that insulation to do its job. And so what happens is heat energy is stolen from the equipment, causing the equipment to not be able to do its job properly, and causing the particular facility to have to provide more fuel to create additional heat to replace what was lost to the atmosphere. So water is an excellent conductor of heat energy, and that heat energy is transported like a conveyor belt to the atmosphere to the tune of billions of dollars of heat energy lost on a daily basis if we don't keep the water out. So the whole concept is to show and prove through testing what is happening in the laboratory, where the insidious nature of the water getting into water absorbent insulation systems to transmit heat energy to the outside. What we're also doing is causing the steel underneath to actually corrode away. The term created for that back in the 1960s was CUI, corrosion under insulation. So now we have, our plants have become the victims of this insidious and very dangerous, because it's unseen, corrosion. And so we have an epidemic going on throughout our industrial facilities around the world. That has cost us trillions of dollars of maintenance and repair. And now what we are seeing are a tremendous need for repair and replacement of equipment that has operated for decades in these adverse conditions. Many mechanisms that are pertinent to what happens inside the equipment are at play. But what is happening is most people do not understand the mechanism and how the old technology insulation that industry used prior to the 1970s and throughout the world is still happening today, because so many countries have not educated their technical people and the specifiers of these materials, which heretofore have been considered commodities. You would not care what your house was built of as long as it was built of stone or brick. You don't care what kind of stone or brick. That is not the case for these types of engineered products any longer. So along with debunking multiple myths about how this type of corrosion occurs, it's not occurring due to the lack of insulation. It's or lack of a coating, a protective coating. It's occurring due to the fact that the insulation is the wrong type of insulation. So we have types of insulation that do not breathe and allow water vapor to escape, so the water can be dissipated to the atmosphere and allow the system, the insulation system, to dry out. And when that doesn't happen, we have very long durations of moisture contact. And as long as you have moisture up against a hot surface, you will have an electrolyte by which the electrical process of corrosion occurs. So as we come to understand this in the Western world, we have a lot of catching up to do in other parts of the world where very, very complex equipment, such as floating production, storage, and offloading facilities, huge multi-billion-dollar facilities, are being built and specified today by people who don't understand these mechanisms and who are putting this equipment that contain very high temperature, sometimes under very high pressure and high flammability conditions, at risk. And if this type of condition occurs underneath an insulation system and it is not monitored properly, then what happens is we end up with a very dangerous situation where very little number of millimeters of steel are between the people that work on this facility and their demise. So our call is to show people and educate people what lessons we have learned throughout our industry to let them know that very small amounts of water inside of thermal insulation have a very large negative impact on both the efficiency of the insulation itself, causing us to spend tremendous amounts of energy, tremendous amounts of money to replace that energy unnecessarily, and also expose our equipment to very, very dangerous rates of corrosion. So when we look at the amount of energy that is lost, we have to scratch our heads because it's an invisible thief. It disappears without our knowing it. It is almost never analyzed and almost never measured. So what we end up with is a lot of lost resources, and our very large operating facilities are being put at risk. What we have as an example to show, when you actually measure the thermal conductivity of an insulation system, this one being very commonly used around the world, sadly to say even today, it is in millions of square feet of facility. And when that amount of material, 1 foot long, 6-inch diameter pipe has the very common thickness of 2 inches of mineral wool, and it only has absorbed 12% by weight of water, because insulation systems are never maintained properly. In fact, they're never maintained at all. Water easily gets into them every time it rains. And when that insulation is water absorbent, it's old technology. It should never be allowed to be used, but it is being used around the world. It is legal to do so, and people who don't know any better are specifying it. And when that happens, not only are we losing many, many millions of dollars worth of energy, but we are also putting our equipment at risk. So if you look at the actually calculated number of BTUs per year per linear foot being lost from just this very small amount of water inside this absorbent insulation, and compare it to what it would lose to the atmosphere if it were completely dry, you can see how much that could cost a facility that is the size of many cities around the world, itself, with hundreds and hundreds of kilometers of piping and large surfaces of equipment being exposed to Mother Nature. When we look at what, and this is hard, I can't show you these slides to show you what the degradation mechanisms are, because they are animated, and I didn't anticipate how they would be not usable for me today. But we have a complete unknown around the industry that I'm trying to voice how to utilize the value of the insulation, the value of the heat energy, and the value that we can mitigate being used up unnecessarily, having to replace equipment, if we would just use insulation technology that is available today. We have hydrophobic materials that will remain hydrophobic up to 315 degrees C. This is an aerogel filled, aerogel is the fine powder. This is an aerogel filled fiberglass blanket. It is a one size fits all as compared to a older hydrophobic technology that's been used on the US Gulf Coast for about 45 years. We have mitigated corrosion under insulation and unnecessary energy loss in some flagship size refineries on the Gulf Coast, some of the largest in the world, for many, many years. This type of new technology This is a relatively new version of a hydrophobic technology that does not use aerogel. It takes the fiberglass blanket and impregnates it with PTFE, otherwise known as the brand name Teflon. The patent on Teflon has long expired. But this process patent now is in effect and is being used around the world, this material. It does not have dust. It is not a nuisance and a skin irritation to be used by contractors to fabricate it into all different shapes and sizes to wrap around our piping. It doesn't require a specific molded size. It can be used very, very efficiently, both onshore and offshore, because of its cleanliness to utilize. And it is very easy to cut, and it is reusable. The thing about these insulations that is different from the rigid insulation types that have existed throughout history and up until today, and still are being used today, is that we don't have to order sizes to fit specific piping. We only use rolls that come like carpet that we unroll, cut what we need, and go and put it on very easily with much less volume needed. It doesn't take up storage footprints, and it is very easy to transport very large volumes of material to accommodate these very, very large facilities that we deal with. The hydrophobic nature of this and its reusability allows a facility to increase its mechanical efficiency. And when we can take the amount of outage time that a facility may have a fluid catalytic cracking unit that makes motor gasoline, that unit, when it's operating, is worth $1 million per day to a refinery, to a large refinery. If that 10-week turnaround can be shortened because of some mechanical efficiencies that technology now affords us, we can gain that many millions of dollars of resources and profit for the cost to the energy company that it costs to make fuel, to make motor gasoline or jet fuel or any other type of fuel or raw material for pharmaceuticals. When the oil industries can keep their costs to a minimum, then that is passed down to the rest of the world as customers. So what we have today is a overall advantage of this technology that allows oil companies' bottom line to be reduced. We reduce our corrosion under insulation, and we have really saved billions of dollars annually and reduce safety risks imposed on our personnel in all of these sometimes dangerous places to work. So I am challenging all of the organizations inside of these industries that are out there transforming raw materials into usable fuel for our world and power generation and all other types of energy for us to use, and to allow us to become smarter about how we do that and the technology with which we do that, so that we can utilize that technology wisely and eliminate these mechanisms that are putting equipment and people in danger. So I know I've shortened this quite a bit because it is probably not of very large interest to most of you in the audience. So I'd like to be able to answer your questions.